Hello and welcome to this session. I am your lecturer, Natalia Francois, and in this session we'll be looking at the time value of money. So the role of time value of money in finance. So time value really refers to the observation that it's better to receive money sooner than later because the money that you have today, you can invest it and you get a positive return later on than just spend it. So for that reason, a dollar today is worth more than a dollar in the future. Now in business, managers, they have to constantly make the trade-off of spending money today and determining the cash flow that will be generated for the next years or for the future. Right? So managers, they need a set of tools to help them compare these cash inflows, money coming in, or outflows that occur at different times. So we use this reference, or we use this concept of time value of money, even in your personal life. So suppose a firm has an opportunity to spend $15,000 today on an investment, right? It could be an investment of an equipment that would produce $17,000 spread over 5 years. Is this a good investment? Yeah, it might seem so because we spend 15 and we are able to get every year 17. We're able to make back the 15 plus 17 at the end of plus 3 at the end of 5 years. So it might seem like a good investment, but if you had the opportunity for another type of investment, which one would you take? So time value is going to explore the value of money in time. So when we talk about time value of money, we are looking at the present and the future value, right? Time, we're talking about present value and future value. Now, what's the difference? Present value is the value of money at today's point in time. So if I invest $10,000 today in a bank account that gives a 5% interest, how much money will I get back in 5 years from today? All right, so we're exploring the value of the money today at a point in time. Future value now is the money at some point of time in the future. So let's say I want $50,000 5 years from today, maybe a down payment on a car, right? From 5 years today, how much do I need to invest in a bank account today that has a 5% interest? We're going to explore these areas of time value, present and future value. Now we have computation tools to help us with doing this type of calculation. So it's called computation tools. So we have financial calculators, finance calculators. They are pretty expensive and they give you the area so you can do these calculations. Then we have, well, I can't afford a finance calculator, so I found an online financial calculator. So with the online financial calculator, I just put in the parameters and it computes the information that I need. It works just as good as the physical financial calculator. Some experts, we use Excel. Excel gives the same areas to help us do this type of computations. So the functions on Excel, the functions help us with present value, calculating future values of different cash flows. Now we're going to learn to use each one of them. Our basic pattern of cash flow. So cash flow usually follows a pattern. Either a single amount, so you get a lump sum at some future date. When we say single, it's one. Annuity is a period of streams of cash flow, so most likely it's equal streams of cash flow. And you hear annuity might be familiar with pension because it's an equal stream you're putting every month or year towards your annuity in the future. And fixed stream is a stream of unequal periodic cash flows. So take note of the three patterns. We're going to look at the three of them and we're going to explore each one in present and future time. So single amounts, future value. Future value again is a value at a given future date of amount placed on deposit today, earning an interest of a specified rate. Now, when we talk about future value, we're always talking about compounding of interest. So compounding of interest that is earned on a given deposit and has become part of the principal at the end of the specified period. So after the first year, interest is added to the original amount, and then interest is applied now to the original amount plus interest. So let's do an example to show the effects of compounding. The example says if Fred Moreno places $100 in his savings account paying 8% interest compounded annually. At the end of 1 year, he will have $108 in the account, right? So 100 plus 8% is interest. The future value equation here, we have Fn, look at it on the left. Future value is equal to present value times 1 plus the rate over the number of periods. So using our financial calculator, we plug in the figures. So if I go back to the computation tool, you'll see N represent the number of periods, I represent interest rate, PV represent present value, PMT represents the payment amount, FV represents future value. So the example says if Fred Moreno places 100 in his savings account paying 8% interest compounded annually, at the end of 1 year, he will have 108 in his account. The initial principal of $100 plus 8% in interest. The future value at the end of 1 year is calculated by using the equation 5.1, it's right across here, present value times 1 plus R. R will represent the rate of return or interest rate and represent the number of periods, present value. So we're trying to find the future value, right? We're trying to find what he will get in the future, which is 8% of 100, 108. Come year 2 now. 8% wouldn't be applied to the $100. 8% is now applied to 108. So the new present value becomes 108 times 108 times 1 plus interest, right? Or we could use it, we can do it the other way or use the formula for the 2 years. 100 is the present value, 1 times the rate to the n or number of years power. So this is how you work it with the equation. Now let's use the financial calculator, online financial calculator. I'll put the link for you in the description box. Present value is $100. Now it's negative because it represents an outflow. So once you're putting in the money, it represents an outflow, so it should be negative. So we enter our PV, we enter our period, so it's 1 period, N will be the period or number of years. PMT will represent the payments. There's no payment amount, there's only one amount. IR will represent the interest rates or rate of interest. And then what we want to calculate is future value. So we click on the future value and we get 108. Come year 2 now, not come year 2, if we are computing for 2 years, we have the present value, which is 100. We have the number of periods, no payment, payment is 0, and we have the interest rates. And so we get our answer 116.64, which is the same as the equation. Simple. So that's for future value, single amount. Right, so what we really have here Let's look at another example. Jane Foster places 800 in a savings account. So should you place 800 in a savings account, this savings account is paying 6% interest compounded annually. She wants to know how much will be in the account at the end of 5 years. So 800 today, invest for 5 years at an interest rate of 6%. How much will be in the account at 5 years? So I'm asking you, what is the future value? So in our Excel spreadsheet, this is how you set it up. Two tables, A and B, present value. Remember, it's an input, it's an inflow, so it's always negative. Rate of interest, 6%, number of years, 5. Future value is computed by entering the values here. So you do the fx function and you get FV open brackets and you select or you type in cell, the cell for the present value. You calculate the cell for the rate, annual interest rate, the cell for the number of years, 0 because there's no payment amount, B2 represents the present value amount time, comma, 0, no interest rate, no payment, close the brackets, and it computes for you. So it's your turn to try it, right? And again, they ask you to remember that 800 is always a minus because it's an inflow of cash, right? It's the initial investment. Using the online calculator, so this is the online calculator, put the link in the description. Notice the fields. So present value, we are trying to find future value, so we won't have anything here yet. Period, payment, there's no payment, interest rate is 6, and then we click on FV and it will give us the amount. So it really tells us 800 invested today and 5 years with interest compounding will be $1,070.58. So that's future value for a single amount. Let's look at present value now. What is the present value of a single amount? So the current dollar value of a future amount, the amount of money that would have to be invested today, given a interest rate over a specified period. So when we calculated future value, interest was compounded. When we are calculating the present value now, we have to discount the cash flow. Discounting means the process of finding the present value, which is the inverse of compounding interest. So let's demonstrate. Let's do this one first. Paul Valentine wishes to find the present value of $1,700 that she will receive 8 years from now. Palm's opportunity cost is 8%. So substituting future value, we have the future value. We want to find the present value. So to find the present value, is future value over 1 plus R interest rate, close the brackets, to n power. Right? So sometimes these equations might take long. So that's why we have the computer. That's why we have the computer tools, right, to help us. So we plug in the figures in the computer. We have the future value, the online calculator, sorry. We have the future value 1,700, number of periods 8, 0 payments, interest rate 8, and we click on PV to get the present value. Excel, we follow the same formula that they have here, and it computes to the same amount. So it means that to get 1,700 in 8 years at an 8% interest rate, we have to invest today $918.46. This is another example. How much money? Paul Shorter has an opportunity to receive $300 1 year from now. If he can earn 6% on this investment, what would he have to pay now to get $300 at 6% investment? Again, this is the equation where we have the future value 300, 1 plus the interest rate, right? It's 1 year, so n will be equal to 1. In the financial calculator, when we plug in the figures, we have the future value, we have the number of periods, 1, we have 0 payments, and interest rate is 6. And we click on PV, and it gives us our answer. So $283.02 will be invested today to get $300. Now that's a single amount. So now let's look at annuity now, which is the stream of equal payments or equal cash flows. It could be payments or cash flows, right? So this cash flow can be inflow of returns earned in investments, or, as I said, outflow of funds invested to earn future returns. So now when we talk about annuities, there are 2 types of annuities. Ordinary annuity, an annuity for which the cash flow occurs at the end of each period. So let's say you're making your payments towards your pension annuity. You're making it at the end of the year. Annuity due now, for which the cash flows occur at the beginning of the period. So maybe you're making your payments at the 1st of January. That would be an annuity due. Ordinary annuity would be one at the 31st of December, the end of the period. Now, the example says Fran Abraham is evaluating 2 annuities. Both are 5 years, 1,000 annuities. Annuity A is an ordinary annuity and annuity B is an annuity due. To better understand the difference between these 2 annuities, she has listed the cash flows in table 5.1. Note that the amount of each annuity totals $5,000. Look at it. The 2 annuities differ only in the timing of their cash flows. Right, so we said ordinary annuity is at the end. So we see year 0 at the end, we pay 1,000, while annuity B is at the beginning. So what you notice, annuity B or annuity due, it pays the cash flows faster. So which one would you prefer? To get your payments or make your payments at the end of the period or at the beginning of the period? In finance, we basically or mostly deal with ordinary annuity, but it's important to understand it too. So we're going to look at ordinary annuity due, present value, because we're looking at time value, present and future value. And we're also going to look at annuity due, present and future value. Example, Braden Company, a small producer of plastic toys, wants to determine the most it should pay to purchase a particular ordinary annuity. The annuity consists of cash flows $700 at the end of the year, so we know it's an ordinary annuity for 5 years. The firm requires the annuity to provide a minimum of 8%. So from here, we can see it's asking what is the present value, right? The annuity consists of cash flows of $7,000. So present value, we want to know that. Future value, 0, we don't have that information. Period, a number of years, 5, interest rate, 8, payment, we have 700. So we use a formula. You see the formula is very complicated, or we use our financial calculator. We want to find PV. So we have the period 5 years, we have the payment 700, we have interest rate 8. So we click on PV and it gives us our figure. If we perform the function in Excel using this formula, right? So you create your table and your values, and then you use the formula to find present value, you get the same thing. So it really means in the present value of 700, 700, 700, 700, 700 over 5 years at an 8% interest is worth today $2,794.90. And you should due. Alright, I did forget the future value for ordinary annuity. So ordinary annuity, future value. So we just did present value, future value. So the present value, future value, remember interest is compounding. Fran wishes to determine how much money she will have at the end of 5 years. So we have the period. If she chooses annuity A, the ordinary annuity, she deposits $1,000 annually. So we know we have the payment, we have the period, and then of the next 5 years into a savings account, paying 7%, we know as the interest rate. So she's paying, this is what she's doing, $1,000 every year for 5 years at an interest rate of 7%. What is the future value of her amount? Well, we know we should be putting $5,000, but what is the value at 7%? Now this is the formula. Right, we could plug in the figures and we would get $5,750.74. So her $1,000 compounded for 5 years is worth $5,750.74. In the online calculator, we are trying to find the future value. We have the period, we have the payment, we have the IR. We have 0 for present value. So the future value of her money is $5,750.74. And the same thing with the Excel sheet. Create your 2 tables and you use this formula here to get your future value. Alright, so we just did an ordinary annuity future value, ordinary annuity present value. Now we're going to look at annuity due future value compounding. Alright, so Fran Abraham wishes to determine if she chooses annuity B, the annuity due, she will invest the same $1,000 at the beginning of each year for the next 5 years. So look at it, annuity due, she's putting the money in the beginning as opposed to end. You realize she's getting more, right? Because her money is able to compound faster because she's doing it at the beginning of the year. Same principle applies with your calculator. So we have the future, we have the period, we have the payment amount, we have the interest rate, and we want to calculate the future value. Same principle applies with the Excel sheet. So it's your choice of use, or you can use your formula. Let's look at the present value now. Present value now is discounting. Discounting the $700 invested over 5 years at the beginning of the period at 8% interest rate. It's $3,018.49. $3,018.49, $3,018.49. Now let's look at it. So we realize annuity due you get more money at the future value. What about annuity due at the present value? Ordinary annuity gives us $27.94, while future value gives us $3,018. So it's better to have annuity due, making our payments at the beginning of the period. Well, it depends on if it's an investment. If it's for a purchase, then you might want to choose the ordinary annuity. So comparison of annuity due with ordinary annuity due. The present value of an annuity due is always greater than the present value of an otherwise identical ordinary annuity. We can compare it as we just did. Now, because the cash flow of annuity due occurs at the beginning of the period rather than the end, the present value is greater. If we calculate the percentage difference in the values of the two annuities, we will find the annuity due 8% more valuable than the annuity. So we just take the figures from the annuity due divided by ordinary annuity divided by the original ordinary annuity, give us an 8%. Now there's something called the perpetuity annuity. Deals with it in the present value. It's an annuity with an infinite life, providing continual annual cash flows. So I don't know if you have an annuity and it tells you that, or pension annuity, and it tells you that it will pay you a lump sum when you retire for life. This is what you call a perpetuity annuity. And this is the formula to find the present value of all these cash flows that you put in. So Ross Clark wishes to endow a chair in finance at his alma mater. The university indicated that it requires $200,000 per year to support the chair, and the endowment will earn 10% per year. To determine the amount Ross would give the university to fund the chair, which is the present value, we must determine the present value of $200,000 perpetuity discounted at 10%. Using the equation, we determine the value. So here we have for the present value, cash flows each year, $200,000 divided by 10%. So the present, you need to give them $2 million. So in other words, to generate $200,000 every year for an indefinite period requires $2 million today if Ross Clark alma mater can earn a 10% on its investment. The university earns 10% interest annually on the $2 million it can withdraw. It should be $200,000 per year indefinitely. So for the rest of their life, they can withdraw $200,000 if he gives them, or he invests $2 million at 10% every year. Then we have mixed streams. So we dealt with single amounts, we dealt with annuities, now we're going to deal with mixed streams. So the mixed streams, we said, there's an unequal payment. So the annuity, where we had $1,000 every year, this one, we don't have $1,000 every year. Maybe we're going to pay what we can pay every year, or if it's a purchase of equipment, is going to return different amounts to us every year. So mixed streams represents unequal cash payment. So we talk about compounding for present value, for future value, and discounting for present value. Now let's see what's happened with mixed stream. Calculating future value. Sherrill Industries, a cabinet manufacturer, expects to receive the following mixed streams of cash flow over the next 5 years from one of its small customers. So end of the year, $11,500, year 1. Year 2, they hope to get $14,000. Year 3, $12,900. Year 4, $16,000. Year 5, $18,000. This is the flow of cash flows they hope to get. Now, Sherrill expects an 8%. So we already see we have the payments amount. and we have the interest rates. How much will it accumulate by the end of 5 years if it immediately invests these cash flow when they are received? The situation is depicted in this timeline. So it's really telling us every year this is what they're going to get. If they take this money and they invest it in an account that's giving them 8% every year, how much will they receive? Now we use the Excel spreadsheet for this one because it's different streams of payments. So you place your two columns, interest rates, year, and then we place the number of years and the amount for each year. So year 1 was 11,005 and so forth. And we're calculating the future value because we want to find what's the value we would get at the end of 5 years. Negative future values, we're putting in this in the Excel spreadsheet equal negative future value, open brackets. You select cell B2, interest rates. You select cell A8, which is 5, number of periods, 0, comma, net present value, open brackets, B2, 8, and then you select all the cash flows. Close the bracket, close the brackets. Right? The brackets are important if you want to get the future value of a mixed stream of income. So, interest compounding for 5 years with the different streams give us 83,608.15 cents. The present value now is discounted. Same principle applies. So in this example now, Fred Company, a shoe manufacturer, has been offered an opportunity to receive the following mixed streams of cash flow for 5 years. So year 1, 400, 800, 500, 400, 300 up to year 5. The interest the firm may earn at least is 9%. 9% every year. So 9% on the 8, the 9, 9%, 9%, 9%. We use the Excel spreadsheet because we are discounting, we use net present value. Right? Open the brackets, select B2, and then come on, select the streams of cash flow to get your present value. So the present value will be 1,904.75. So it just simply means that he should spend 1904.75 if he expects to get these returns every year with our 9% interest rates. Now we talk about compounding interest. We compounded interest in these examples annually, but interest is sometimes compounded more frequently than annually. Especially in savings institutions and banks, interest is compounded, can be compounded semi-annually, that's twice per year, quarterly, that's 4 times per year, monthly, that's 12 times per year, or weekly, that's 52 times per year, or daily, 365 times per year, or even continuously. So you would see if you have an investment account, like a unit trust, it says interest is compounded daily. That means 365 times. So when we say more than one time, before we were just using like 8% on the year's amount. This time we need to calculate one day, if interest is 8% on your $100 is 108. The next day, interest is compounded on the 108. The next day, the interest is compounded on the 116, and so forth and so forth. So semi-annual compounding of interest over 2 periods, right, and quarterly, right, to explain that. So let's look at an example. Fred Moreno would have at the end of 2 years if he deposits $100 at 8% interest compounded annually. compounded semi and compounded quarterly. So we're working semi and quarterly. What do you think will happen? Before we just had one period. So we want to know the future value. We have the present value is the $100. The period, it's not 1 year if you're doing semi-annually first. It's not 1 year, it's not 2 years, sorry. Semi would mean there's two in a year, so the period would be 4 years, right? So this is simply taking the 2 years multiplied by 2, and we got the 4. What about the interest rate? Interest rate is compounded annually. If you're compounding it semi-annually, 8%, so that means 4% each year. So for 2 years, 4% each year. Interest rate is calculated 4 times. So we're using 4, 1, 2, 3, 4, 4 times a year. That is 8 divided by 2. 8% divided by 2 years. So our future value should be equal to 160.19. So this is when interest is compounded semi. But what about when interest is compounded quarterly? We have PV is equal to 100. Period is equal to, what's that, 4 times? 4 times a year by 2 years is 8 years. 8 periods, sorry. Interest rate now is now 8 divided by 4 times. 8 divided by 4 times a year is now 2%. And we plug in the figures, so our future value is now 117. Right, same principle applies with the Excel spreadsheet using the formulas. Right, or this is the equation here. So if it was the compound interest, the daily, it will be multiply the periods by 52, right, and divide the interest rates by 52. Not daily, weekly, sorry. Now let's put all this into a real perspective. We're going to determine the deposits needed to accumulate a future sum. So suppose that you want to buy a house in 5 years from now. I spoke to a student this morning and she said she needs to buy a house in 5 years from now. And you estimate that your initial down payment is $30,000 will be required at that time. To accumulate the $30,000, you will wish to make equal annual end-of-year deposits into an account paying an annual interest rate of 6%. So you have an account that's paying 6%. You want to get $30,000. To solve this problem, it's closely related 5 years to the process of finding the future value of an annuity, right? You must determine what size annuity will result in a single amount of $30,000. So how much would you need to put every year at the end of each year to get $30,000 at the end of 5 years with a 6% interest rate? So we have the equation there, or you have the calculator. So we know what we have. We have the future amount. We know we have the number of periods. We know we have the interest rates, but we need to determine those equal payments per year. So we click on payments and we need to put in $5,321.89 at the end of 5 years, at the end of each year for 5 years to get $30,000. I'm sure this example will be applicable to some of you. You can do this and you have $30,000 in the next 5 years to put towards some investment goal. Now you'd hear about loan amortization. This is where time value of money applies as well. So the term loan amortization, if it's the first time you're hearing it, it refers to the determination of equal periodic loan payments. So the bank uses it. These payments provide a lender with a specified interest return and repay the loan principal over a specified period. The loan amortization process involves finding the future payments over the term of the loan whose present value and the loan interest equals the amount of initial principal borrowed. Lenders use a loan amortization schedule to determine these payment amounts and the allocation of each payment of interest and principal. So it may really says if you have taken a loan before, or if you ask your parents, when you make your loan payment each month, so your loan payment is $1,000. Some will be going to the principal, some will be going to the interest. The interest is usually paid off before. So after the interest is paid off, so the 1,000, let's say 800 might go to interest, 200 might go to the principal of about $30,000 you borrowed. And then the next payment, you'll have $750 going towards interest and the rest goes towards principal and so forth and so forth. So it's a scheduled billing. It's usually in case of home mortgages, this table used to find equal payment amount. So even though you're paying per month equal amount, different amount is going towards principals and different amount is going towards interest each payment time. So amortizing a loan actually involves creating an annuity out of a present amount. For example, say you borrow $6,000 at 10% and agree to make equal annual end-of-year payments over 4 years. To find the size of the payments, the lender determines the amount of the 4-year annuity discounted at 10%. So we can use an Excel spreadsheet here to determine this amortization. We have present value, the borrowing. We have the annual interest rate, we have the number of years, we have the annual payment. Give us our annual loan payment. Now I should use this on a calculator. Let me do an online calculator to demonstrate to you. Right, so this is the online calculator, and let's say we have the present amount is 6,000. We have the period 10 years. I can't remember. 6%. Future value is 10,745. 10% and 4 years. Sorry. So this should be 10%. 10%, period is 4 years. And the present value is 6,000. payment amount is, well, this shouldn't be negative, it's positive. Payment amount each year is $18.92. So let me do that again. We have the present value, so the bank gave you $6,000 over 4 years, right? So the bank is giving you $6,000 over 4 years, and their interest rate is 10. Let me do it again. So we know their interest rate is 10%. They're giving you $6,000 over 4 years. How much is your annual payment? $1,892.82. Right? So you can use this example and this calculator if you are determining your payment amount, if you're considering some kind of loan payments. So that's loan amortization. We also use this principle of time value in finding interest rates or growth rates. So sometimes the bank don't give you the interest rates, but you know you have your payment amount. In the simplest situation is one in which an investment value has increased over time, and you want to know the annual growth rate. What's the growth rate? That is represented by the amount. So the example says Ray Noble purchased an investment 4 years ago. 4 years ago for $12.50. Now it is worth $15.20. How much has it grown? What is the compounded annual rate of return had Ray earned on this investment? He was never told how much interest rate is paying, but he realized over 4 years his investment grew. So what is his calculation? Again, you have a formula here, but with your online calculator, we have the present value, how much he invested, $12.50. We have the future value, which is $15.20. We have the period is N. What we want to find is the interest rate, 5%. Right, when I use the formula, we found the same thing. Excel spreadsheet again, find the same thing using the formula. Now finding interest rate on growth rates. Finding interest or growth rate. So we find this one was growth rate. Now we want to find interest rate. Jan Jacob can borrow $2,000 to be repaid in equal annual end of month payments of 515 end of year amounts of 14 cents for the next 5 years. She wants to find the interest on the loan. How much is the interest on the loan? We know the present value. The bank given her $2,000. We have the number of periods, 5, and we have the payment amount. What is the interest rate? 8.9919%. This is how you apply the time value of money. I think this is the last one. Finding an unknown number of periods. So we just found the interest rate. We've learned how to find the payment. We learned how to find the present value, the future value. Now we're going to learn how to find the number of periods. So sometimes it's necessary to calculate the number of periods needed to generate a given amount of cash flow from an initial amount. Here we briefly consider this calculation both for a single amounts and annuities. So Ann Bates wished to determine the number of years it will take for her initial $1,000. So she's putting $1,000 in an account that has an 8% annual interest to grow and equal 2.5. Simply stated, at an 8% interest rate of interest, how many years will it take for Ann's $1,000, this is her present value, to grow to $2,500? So she's putting this $1,000 in the account, present value. She wants to get a future value of 2.5. The interest on the account is 8%. How long will it take her? 11.9 years. Right? With Excel, it's consistent again using the formula NPER. So if you've calculated the period, you've learned how to calculate the future value, present value, you learned how to calculate the payment amount and the interest amount. And that's how we describe the time value of money using the computation tools. Have a good one. See you in the next session.